Welcome to Digital Electronics and Microprocessors, Unit 5. In this unit, the second part is about 8051 microcontroller. So, coming to the introduction, so the microprocessor is a programmable chip that forms the CPU, central processing unit of a computer. It is also the microprocessor is also called CPU on a chip. So nowadays, many microprocessor chips are available in the market. So for users to select from depending on the application. So in general, microprocessors or process chips can be classified as general purpose processors, microcontrollers that is used for specific purpose, and digital signal processing process. Coming to the microprocessor based system, the microprocessor based system consists of a CPU of a digital computer as a microprocessor, and it needs external components such as memory, input devices, output devices, and timers, serial communication port, and decoders to function as a microcomputer system. So these chips can be used to suit any general purpose applications, yes, and can be configured by the user. We can configure, user or programmer can configure. So the examples for this processor, there are 4-bit processors, 8-bit processors, 16-bit, 32-bit, like that. The examples of 8-bit processors are Intel's 8085, Zilog 80, and Motorola 6800. For 16-bit processors, Intel's 8086 and 8088 and Motorola 68000, and examples of 32-bit processors are Intel's 80186, 80286 and 80386 and Motorola 68030 are the examples for 32-bit processors. So in general, these microprocessor based system get data from mass storage device, that is external memory, performs calculations and store the results in the storage devices, that is external memory, that is RAM or ROM. So general purpose microprocessors use external memory, and a lot of processor time is involved in data transfer between the external memory and the processor. And coming to the microcontrollers, so this is the block diagram of a microcontroller. It has CPU, RAM, ROM, IO device, timer, serial communication port, and uh, other blocks in a single chip. So it is called microcontrollers or processor chips that generally have memory, input or output ports within the chip itself. So that's why the microcontrollers, therefore, they can also be called as single chip computers or computer on a chip or system on a chip. So microcontrollers are used in machine control applications where there is no need to change the program. So equipments that use microcontrollers include computer printers, plotters, fax machine, Xerox machine, telephones, automotives, engine control mechanism, and electronic instruments such as oscilloscopes, multimeters, plane meters, IC testers, even washing machines, right? Washing machines, micro ovens. So there are, the microcontrollers are used in as embedded systems. Okay, so that's why the microcontrollers we can find in all these equipments. So you can see here, this is the block diagram of a general purpose microprocessor system. This one CPU is there, and memory, IO devices, timers, all are externally connected with a address bus and data bus. So for this one is these are the different parts you can see. So this is the block diagram of microcontroller. Here you can see this all these parts, CPU, memory, right, AD converters, and all these oscillator, all these are available in a single chip. This is a single chip. So this is called microcontroller. So now coming to the differences between microprocessor and microcontroller. So this is the block diagram of microprocessor, and this one is the block diagram of microcontroller. Here the microprocessor is the heart of a computer system. Microcontroller is the heart of embedded system, and if it is just a processor, memory and I/O components have to be connected externally, but microcontroller has external processor along with internal memory and I/O components. You can see I/O processor and memory. So since memory and I/O has to be connected externally, so the circuit becomes large. So here the memory and I/O are packed internally. The circuit is very small. Microcontroller circuit is very small. So here the microprocessor cannot be used in compact system and hence inefficient. So it can be used in compact systems and hence it is an efficient technique. So cost of the entire system increases for microprocessor and cost of the entire system is low for microcontroller systems. Here, due to external components, the entire power consumption is high in microprocessor-based system. Coming here, since external components are low and total power consumption is less in microcontroller systems, so most of microcomputers do not have power saving modes features. But coming to 80, that is microcontroller, it has power saving modes, idle mode, power saving mode, like this. And since memory and IO components are all are external, each instruction will need external operation, hence it is relatively slow, right? It always connects with memory, interacts with microprocessor always interacts with memory, so it it needs time, so it is slow. Coming to microcontroller, since components are internal, most of the operations are internal instructions, hence speed is fast. So microprocessor has less number of registers as more operations are memory based. Microcontrollers have more number of registers, hence the programs are easier to write. So microprocessors are based on von Neumann model, that is architecture, and microcontrollers are based on Harvard architecture. So mainly used in personal components, here used in washing machines and MP3 players, etc. There are many applications. There are many devices, equipment uses microcontroller. So the major difference between microprocessor and microcontroller is that microcontrollers are comparatively faster because of reduced external memory accessing. Examples of microcontrollers are 8031 microcontroller, 8051 and 8096, and Motorola's company developed 68HC11 are examples of microcontrollers. So coming to DSP process, so digital signal processing chips that have flexibility in hardware and software to implement signal processing. So these processes have an extended arithmetic and logic unit for operations of floating and fixed point number operations. So like microcontrollers, DSP processors also have on-chip memory, IO ports, A to D converters and serial ports. They are used in mobile phones, digital cameras, PBX systems and smart card readers. So coming to Intel's uh, microcontrollers family 51 series. So Intel Corporation has many microcontrollers in both 8-bit and 16-bit configuration. The 8-bit microcontrollers in many part numbers MCS51 as the family name. The various MCS51 series microcontrollers, for example, 8XC51RD comes with internal ROM of 64 KB, while 8XC51FC comes with only 32 KB ROM. So this is, you can see here, first 8XC51. It has 4 KB of ROM, and 8XC5152, 8XC51FA RA has 8 KB of ROM. This one is, it has 16 KB of ROM, 32 KB, 64 KB. So here ROM indicates the program memory. Coming in this table, you can observe that each and every microcontroller has what is the data width of the microcontroller and what is the RAM capacity and ROM capacity. ROM capacity of it. Now all these microcontrollers developed by Intel microcontroller. Intel. So in Intel corporation has many microcontrollers. Yes. So all the microcontroller chips listed above have the same basic architecture. Okay. So coming to 8051 microcontroller architecture, the main features of 8051 chip are 8-bit CPU, 4 KB. It has internal memory, RAM and ROM. So here 4 KB of on-chip program memory and 128 bytes of on-chip data RAM, 4 ports of 8-bit each, 2 16-bit timers, full duplex serial port and on-chip clock oscillator. So in addition to the above features, the 8051 provides Boolean processing and 6 instruct capabilities and full-fledged CPU for control applications. So this is the architecture of 8051 microcontroller. You can see here, this is the ALU and these are the accumulator register, B register, program counter, points that is of next instruction to be fetched. DPTR, the DPTR used as a data point in 8051 microcontroller. It has a 16-bit address bus, PSW program status word, special function registers. This is the ROM, right? So here you can see this block is used to interface microcontroller with external system at computer or memory. So these are the special function areas: entrepreneurial, interpretive, PCON, serial buffers, serial control, TMOD, T control, timer mode control. So these are the register banks, internal RAM, 128 bytes, 10 bit addressable, all these things. So these are the 4 I/O ports, right? And this is also the functional block diagram of 8051 microcontroller. This is CPU and bus control on chip ROM and RAM on chip RAM, timer serial port. All these are connected with CPU. This is block diagram of 8051 microcontroller. You can see the block diagram. There are 4 ports here too, right? So this is the oscillator section, timing and control unit. This is register B, and these are the temporary registers, accumulator, ALU, so this is the block diagram of 8051 microcontroller. So 8051 is an 8-bit microcontroller, that is data bus within and outside the chip is 8-bit wide. The address bus of the 8051 microcontroller is 16-bit wide, so it can access 64 KB of memory, right? The lower order address bus is multiplexed with the data bus as 8085 microprocessor. The port 0 and port 2 pins of 8051 forms the multiplexed address and data bus. So this is the pin diagram of 8051 microcontroller. So it is available in 40 pins, 40 pin IC. So most of the pins are having multiple functions. So 8051 is the power supply is VCC. Okay, 2 pins, VSS 2 pins, built-in clock oscillator requires 2 pins, XL81, XL2 for connecting the crystal. The 4 control signal pins of 8051 are PSEN, ALE, EA and RST. So RST is an active high reset signal to restart the controller chip. So 8051 responds to a RST high inputs only if the RST is held high for at least 2 machine cycles. A machine cycle is the period of that taken by an processor to fetch and execute one instruction. In 8051, the maximum number of clock cycles taken for a machine cycle is 12. So the RST pin must be higher for at least 24 clock periods. So PSEN, ALEA are the signals used in conjunction with the external memory access of the 8051 microcontroller. So coming to memory organization of 8051 microcontroller, the memory is organized logically into program memory and data memory separately. The program memory is read-only type. The data memory is organized as read-write memory. Again, both program and data memories can be within the chip or outside. So the 8051 has 128 bytes of RAM and 4 KB of ROM within the chip. The address bus of 8051 is 16-bit wide, so it can access 64 KB of memory. So coming to 8051 clock and instruction cycle. So in 8051, one instruction cycle consists of 12 clock cycles, and instruction cycle is sometimes called as a machine cycle by the authors. So this is, you can see here, total P1 to P12, P1 to, right, P1, P2, P1, P2 up to 6 cycles are there, S1 to S6. So in 8051, each instruction cycle has 6 states, S1 to S6. Each stage has 2 pulses, P1. So coming to here, the memory, it has two parts, divided into program memory, data memory. The program memory in 8051 microcontroller in 4 KB of ROM, external 64 kilobytes, internal RAM of 128 bytes, external 64 kilobytes. So as the memory is organized separately as program memory and data memory, the 8051 microcontroller can access 64K of program memory and 64K of data memory. The user can configure the entire program memory outside the chip or use 4 KB inside and 60 KB outside the chip, no problem. The internal data memory is accessed with 8-bit addresses and the external data memory with 16-bit addresses. So the maximum data memory that can be connected to the 8051 system is 64 kilobytes. So coming to the internal RAM structure of 8051 has 100 bytes of internal data RAM which is accessible as bytes or sometimes as bits. The address of the internal RAM starts at 00H and occupies up to 7FH. So the RAM space is divided into three blocks. The register banks, one, that is 002, the 000 to 1F, the bit addressable memory, and the scratchpad memory. 8051 has four register banks of 8 registers each. The addresses are from 00 to 1F. In assembly language, they are used accessed by the name R0 to R7. So this is the structure of internal RAM. These are the register banks from 00 to 1F, and this is bit addressable memory. Right, from this is from 3 to 7 byte addressable memory. So the register banks are identified with 2 bits in the program status, process status mode flag register. So the PSW has 2 bits to identify the register bank. 00 represents bank 0 and 1, 01 represents 1, 10 represents bank 2, 11 represents bank 3. Okay, so in the 8051 bitwise operations are also possible with special instructions using the bit addresses. The bit addressable memory is both bit addressable from 00 to 7F and byte addressable from 20 to 2F. Bit address operations are helpful in many control applications. Control algorithms using general purpose scratch and memory programs can read and write data at any time for any purpose. This memory ranges from the byte address 30H to 7FH. So this is a of 8051 microcontroller and memory organization and internal RAM structure of 8051 microcontroller.